Hello, and welcome to the Space for Kentucky Roundtable. The Space for Kentucky Roundtable is a series of meetings focused on growing the space industry. It is about networking, education, and social support for those who are reaching for the stars. We had an exciting week this week as we landed back on the moon for the first time since 1972. And Kentucky was a part of it. Morehead University was a vital part of the ground support involved. Yay! Each Space for Kentucky meeting has a theme. The past several meetings have been focused on spaceports. And if you know me, you know that I love spaceports. In fact, I work with the Global Spaceport Alliance in my current position. Global Spaceport Alliance had a Spaceport Summit on January 29th, and it kicked off the Commercial Space Week with Space Mobility Conference and SpaceCom in Orlando, Florida. According to the 2023 Space Report, there has been a 48% increase over the past 4 years in proposed spaceports around the world. The GSA Spaceport Summit reflected that growth with its largest attendance in history. It was double of that of last year. Representatives from 20 spaceports from across the U.S., the United Kingdom, Sweden, Italy, Japan, Brazil, Australia, Canada, Peru, and Portugal participated, along with representatives from France. I am passionate about spaceports, and I believe that it can bring innovation, education, and inspiration to an area while providing an opportunity for economic growth. Spaceports are where space begins. So what does that mean to Kentucky and places similar to Kentucky? Well, space is here. And we, as Kentucky, have a logistical dream for our area, for our region, for the United States. We also have one of the largest river ports in the country. The rivers that border our state flow down to the Mississippi, into the Gulf, and to Cape Canaveral. So we may not be able to launch rockets, but we can build them. The past 2 meetings, we have looked at how spaceports can impact an area. We had guests like Houston Spaceport and Spaceport America that demonstrated the economic power that a spaceport can bring to an area. Last meeting included aerospace vehicles that can be flown from a horizontal launch situation like Houston and what Kentucky would be. This meeting, we will look at different technologies that launch can be. Space has impacted everything from cell phones to medicine to launch. Tonight, we will meet some individuals that work with innovative solutions to make green launches. Let me begin with a huge thank you to our 3 guests tonight. 2 of them are up quite late for us as they are from the United Kingdom. The UK is just a little bigger than Kentucky and are building not 1, but 7 spaceports. Not only are they doing that, but they intend to do it green. One of the things that I love about space is that it is full of smart people that can solve many of the problems that they're confronted with. Launch pollution is one of those things, and when they solve it, it becomes a part of our day-to-day world. A lot has been done to develop space propellants that are environmentally friendly or green and contribute to non-toxic propellants. Liquid hydrogen and liquid oxygen that are used in the main engines of the space shuttle and in the main stages of the Ariane 5 rocket are clean and burn as steam. From agricultural waste to recycled material, the best and the brightest are looking at sustainable and eco-friendly ways to reach space. We will begin with the subject matter expert, Richard Osbourne, AstroAgency's Chief Technology Officer. AstroAgency and FireArrow focus on spaceport development and promotion. And then we will meet Colonel Robert A. Fabian, United States Air Force, retired, Chief Operating Officer from Vaya Space. Vaya is a Vortex hybrid rocket company based on the Space Coast of Florida with a subsidiary operation in Brazil. And Derek Harris, Business Operations Manager at Skyrora and CEO of Ecosene. Skyrora's mission is to enhance global aerospace outreach by creating convenient, cost-effective, and affordable infrastructure for launching orbital Earth observation facilities. So let's meet Richard Osbourne. Richard Osbourne is AstroAgency's Chief Technology Officer. He has an extensive industry experience across the space value chain extending back to the early 1990s. Previously working as a program manager at the Orbital Launch Company, as well as launch systems, spaceports, and propulsion consultancy for companies including Reaction Engines and Airborne Engineering, as well as system engineering and analysis for numerous space industry projects, including ESA payloads to Mir space station and NASA observation and Russian Mars missions. A chartered physicist, he has a BS honors in physics, a master's in remote sensing and planetary physics, and he has a PhD in solar astrophysics, specializing in stellar magnet hydrodynamics. Oh, that's a mouthful. And solar flares. He is a fellow of the Royal Astronomical Society and British Interplanetary Society. Now you see why I have him as a subject matter expert. So with no further ado, please help me welcome Richard Osbourne.
Thanks, Izzy. I'll share my screen, if I may, to show you my presentation.
Absolutely.
Marvelous. Right, okay. And if we go, I'm trying to get the slideshow up. Can you see it?
We can. Now, if you go to the little slide on the bottom right, you'll see like I don't know what you would call it. Yeah, there you go.
Yeah, there we go. Marvelous. So I'm looking at it generally from the UK angle because that's what I know or what I know best. So I thought what might be useful is to give you a bit of an overview first to explain how the UK has, to some extent, accidentally got to where it has currently. Oh, I don't know what's happening there. That's better. That's what I wanted. So I'm going to break it down into the sustainability aspect, spaceports and green fuel or oxidizer. So first of all, from a sustainability perspective, now the interesting thing is the UK has run quite rapidly on this, and it's gone from a position of not particularly looking at the sustainable aspect, maybe 10, 15 years ago, into really embracing it. And in the process, its launch has been, to some extent, driving the process, but it's been driving it for many years before the whole sustainability agenda became a thing. In terms of the general sustainability, it was Scotland that pioneered the idea behind a sustainable space strategy. This was back a few years ago. And at the same time, there was development ongoing nationally. And that led to King Charles, as he now is, put into putting his seal on a concept called the AstroCarta, which the idea is that there will be a sustainable mark, effectively, for companies that are operating in the space industry in a sustainable way. And the AstroCarta is seen effectively as almost like an update of the Magna Carta from almost 800 years ago. So it's looking at, well, in fact, just over 800 years ago now. And it's looking at taking us into the future in a much more sustainable manner, with space leading the way. So I'll go on to the next slide. So we have, as Izzy pointed out, 7 spaceports in the UK, or 7 spaceports planning on developing. Of those, there are 3 vertical spaceports, and with 2 of those so far that are under development currently, they're planning on developing in a very, very sustainable manner. Now, what do I mean by a sustainable spaceport? It's one in which the footprint of the site is much, much lower than you would normally expect of a spaceport. It takes as little space up as possible for the actual launch infrastructure. There's an effort made to minimize any spills. That would normally be the case anyway, but it's especially the case with these sustainable spaceports. And it even extends to the materials, the infrastructure. Everything is done in a way that minimizes the carbon footprint. And with the 2 launch sites, we have one in Sutherland on the far north coast of Scotland, and one on the island of Unst, and the site is called Saxe-Voord. It's right up at in the Shetlands, which are a group of islands way to the north of even Scotland. And it's a wonderful place. I've been up there, and it's absolutely fabulous in terms of the natural beauty, and you can see why they're minimizing its impact on the environment. And additionally, there's a number of companies looking at launch development services, but one that stands out is a company called Vaya, who are from the outset providing what they maintain is very low footprint launch development services, not just in the UK, but extending around the world globally. So in terms of where we go with the UK in terms of the sustainable spaceport model, I think Sutherland and Saxe-Voord are setting a very, very good standard for the other spaceports to follow. We have to bear in mind that some of the spaceports as well are horizontal, so they have aircraft launching from them. But even there could be potential for space planes, and we'll come on to that in a minute as well. So if I go to the next slide. By way of background, and I thought this was worth pointing out because it's something that not a lot of people necessarily realise, but the UK has actually been using green propellant for a long, long time. Certainly back as far as the 1950s, and the initial testing took place in the 1940s. And the reason for this was after the war, a number of the German rocket scientists came over to the UK And the ones that came to the UK had expertise on hydrogen peroxide, which is why the British went down the route of developing rocket engines with hydrogen peroxide as the oxidizer. And they developed some quite serious expertise around that. So I've listed several of the engines that were tested back in the day, back in the 1950s. And that led on to a large suborbital test rocket powered by hydrogen peroxide as the oxidizer. And in turn, then in the 1960s, that led on to the development of the Black Arrow orbital rocket, which was the first and only orbital rocket built in the UK to date. Although I would hope that Skyrora and Orbex do something to change that over the next few years. So the Black Arrow rocket was developed in the 60s, but launched 2 orbits successfully after on the 4th flight in October 1971. And that marked the high point of using hydrogen peroxide in the classical space age, so to speak, in the UK. We'll come on to the resurgence of that in a minute. So if I go on to the next slide. However, it wasn't the only choice. The ultimate is hydrogen and oxygen. And back in the 1980s, there was a development of an air-breathing space plane called HOTOL that was designed to take off Royce, who were developing the rocket engine, and British Aerospace, who were developing the airframe of the vehicle. And this built on an engine Rolls-Royce had tested back in the 60s called the RZ-20, which was a hydrogen oxygen rocket engine. I was trying to look for a photo of that actually, but I can't find it, but I do have a photo of that somewhere as well. Now, unfortunately, HOTOL, whilst being a fantastic concept, never got the funding it needed in the 1980s. It was one of those political things that politicians don't necessarily always understand the importance of space, although hopefully that's changing somewhat now. But what happened was it led on to a follow-on project called Skylon, which essentially took the best parts of the HOTOL spaceplane to develop a new spaceplane. And that's the image that you see there of that sleek black spaceplane with 2 rocket engines on the wingtips. And that was developed by a company called Reaction Engines. And development has been ongoing on that since the 1990s. And at the moment, they're focused very much on the engine technology. And I spent several years working there back in the mid-2000s. And it's an incredibly exciting project because it means that eventually it will allow a hydrogen-oxygen spaceplane to take off and fly all the way up to orbit as a single stage. Now, a lot of people will rubbish that and say, oh, it's not possible, it's incredibly difficult. But when you, to use the American phrase, do the math, it's actually incredibly compelling. And I have no doubt that eventually it will succeed. I say eventually because it requires sufficient funding to get to that point. So that's the ultimate endpoint in a way. You have a clean engine with hydrogen and oxygen. Effectively, the output, when you think about it, is steam, very, very high temperature steam. So it's the best possible impact you could ever want, because it's such a minimal impact on the environment. In the meantime, there are other green propellants or combinations that are being explored. There's a German company called High Impulse that has been developing a wax-based fuel for a hybrid rocket engine. And this photograph shows a static test of one of their hybrid rocket engines, or rocket motors, sorry, at the Saxe-Ford Spaceport in the far north, in the Shetlands, off the coast of Scotland. And additionally, there's a project by the University of Glasgow for something called a self-eating rocket. And they have actually tested this. I'm not convinced myself that it will work for being scaled up to orbital size. But they have made progress on it, and good luck to them, I say. So moving on past that, we then had the return of hydrogen peroxide in the late 2010s, when Skyrora came on the scene and decided they were going to use hydrogen peroxide in the very best spirit of the pioneers in the UK back in the 1950s and 60s. And in fact, Skyrora did actually have the Black Arrow rocket, the remains of the first stage, in storage for a long period of time. I believe it's now in a museum. It's been donated to a museum, hasn't it, Derek? Yeah. But they're using hydrogen peroxide, which is, personally, I'm delighted to see. It's a fantastic choice. And they're using Ecosene, which is a fuel which Derek will be able to explain far better than I, what and how Ecosene is and how it works and how it's been developed. And then, additionally, as if that wasn't good enough for developing an orbital rocket in the UK, another company based in Scotland, Orbex, are launching from the Sutherland Spaceport, the other Scottish vertical spaceport. And they're planning on using biopropane fuel, which is propane that has been captured, I suppose, for want of a better term, from biological processes, I guess, from something akin to an anaerobic digester. And they're using that with liquid oxygen, and they're hoping to be going to orbit in the next couple of years. So it's all getting quite exciting on the vertical launch side. Well, there's American companies that are looking at launching from Saxe-Ford, for sure. I know ABL are looking at launching from Saxe-Ford. And I'm not sure whether any others are. I know there's been talk of others at various points, but hopefully we will shortly be seeing some very sustainable launch vehicles launching from the far north of the UK. And that essentially wraps up my presentation. There is a genuine commitment to sustainable launch in the UK. The spaceports are proceeding right from the outset with a very low carbon footprint, and the use of green propellants is a real thing in the UK. It is genuine, and it's clearly something that's going to continue long into the future. So on that note, I shall conclude, and if you have any questions.
Yes. Does anybody have any questions about that? That was fabulous. And the the thing that I really want to point out is that when we go to space and we develop technologies for space, that technology comes back down here on planet and will impact us down here. So, space doesn't have any banks, is what the saying goes. It all comes
Exactly.
back down here.
You see, this is something that I'd always try and point out to people when they say, "Oh, why are we spending all this money on space?" And you point out, well, actually, there is nothing in space to spend your money on. It is all spent on the Earth. So, absolutely, I'm so glad you're promoting that message. That's great.
And you look at like some of the things that come down from the ISS, the International Space Station. Our cell phones are a product of space.
Hmm.
So, fuels are going to impact us in how we get around down here. Is battery powered the answer? I don't think so. So I think maybe along these lines is something that may be promising for just how we get around on the planet.
Yeah, absolutely. And hydrogen is certainly something that shouldn't be discounted for the use with fuel cells.
Absolutely. So, are there any questions?
Hi, sorry for joining late. Great presentation, though. I had a question on the waxed-based fuel. When you say wax, is it a form of something, or is it actually like wax as we think of like beeswax or candles wax, or is it like petroleum in the form of a waxy something?
Well, that's a very, very good question. And I don't actually have an answer to that, Paul, other than I've been told it's beeswax, but I'm not sure. And the reason I'm not sure is because the one thing with hybrids, I've done a lot of work with hybrids in the past, and you do have a problem sometimes with propellant as it burns away in the combustion chamber, and sometimes it can come away in chunks. And I'm not entirely sure how what the structural integrity is of beeswax as a hybrid uh, fuel. So I'm not sure is the answer. I've heard it's beeswax, but personally, maybe I should go and try it and give it a go. But I don't know the exact propellant formulation.
And I would like to point out that Paul is developing a spaceport in Paso Robles. And are you looking at horizontal or vertical or both?
Horizontal specifically. We have a former military airfield that the city acquired for $1 back in the 70s that we're just trying to repurpose. And we're an ag town, so we have a lot of bees. So you've got me thinking. And I was just imagining a science fiction film where people living in a space station monitoring their hives and growing their own fuel with bees. That's just anyway. But thank you. That's that's great. But we're working on horizontal. And so when you're talking about the space plane part of your presentation, that was very poignant.
And a lot of your horizontal launch actually shoot off rockets from underneath the wing, like what Cornwall did
Yeah.
in January of last year. So, it's still relatable to how the rocket fuel gets acquired and what it does.
I was going to say some of the space plane people were talking to are exactly at the second stage would be exactly that, would be a rocket from some kind of an airframe.
There is also another side to the whole sustainability agenda with launch, which is not just the green propellants, but reusability. Because the more reusable you can make your launch vehicle, and the less you're throwing away in the long run, that brings down the cost, obviously, but also makes it more sustainable. So that's another thing to bear in mind, that reusability is the route forward. And as Derek knows, I've been arguing with him for ages that they need to put landing legs on their first stage of their Skyrora rocket and bring it back to the launch pad.
Another discussion for another day, I'm sure. So
Oh, that's one for a beer in the pub, I think.
All right. Well, thank you so much. That was awesome. And so next we have Colonel Robert Fabian, retired U.S. Air Force, and he has over 25 years in military space operations and rocket booster sustainment and repair experience. His military career has covered a wide range of military space capabilities, including tracking satellites with radio telescopes and radar systems, planning with the modernization of the Air Force's space control capabilities, and writing Air Force doctrine for planning and executing operations. So he is going to tell us all about Vaya Space, which has a very new type of rocket fuel that is very interesting. So take it away.
Well, thank you, Izzy. It's a pleasure to be here. And to add to that, probably more relevant to the discussion on fuels and launch vehicles today, I spent a good chunk of that career as a maintenance officer for the Minuteman and Peacekeeper ICBMs. So spent a good bit of time handling solid rocket motors and some rather nasty chemical hypergol fourth stages. So give me a second here while I share my screen, and we'll talk a little bit about what we're trying to do with Vaya Space and our rather unique Vortex hybrid engines. All right, we'll go right into it. I think a video is better than one person droning on, so let me give you a real short snippet about what we're about.
Vaya is revolutionizing space and making a difference for humankind, reducing plastics on our planet by taking them off our planet. Vaya Space's launch vehicle, Dauntless, transforms the space industry.
And it goes on and on with marketing speak from there, so I won't bore you with it, but Dauntless, that's what we're doing in Vaya. We it's said on there, it's our reason for existence, to revolutionize space and reduce plastics on our planet by taking them off our planet. We didn't start out to do that, and I'll talk a little bit about how we ended up in our fuel. We are a completely privately owned rocket company focusing on our Vortex hybrid rocket engines. We've been building and testing them for about 7 years now, right here on the Space Coast. And we've got some patented technologies that make our hybrids do things that people generally don't think hybrids can do. So before we get into that, this is Dauntless Block 1. This is what we're gearing up to launch in 2026. Our powered with our Vortex hybrid engines, about 500 kilograms to low Earth orbit, and 7 metric tons of plastics removed from the waste stream with each launch. And how do we do that? Not everybody is familiar with hybrid engines. I know our panel here, we've got 3 people with hybrids experience, and in my experience, that's kind of rare in a panel. But everybody's familiar with solid rockets and liquid bipropellant engines. They're well understood. Solids are simple. There's a lot of history and development on it, but they're relatively expensive, mostly because of operational and handling concerns. You've got a huge chunk of explosives with a nozzle on one end. I can vividly remember time that my wing, not my guys, thankfully, put a Minuteman ICBM downstage, just the engines, in a ditch in a rolled over truck. And it took us almost 3 months to get it out safely. That's not something you want to be handling on a day-to-day basis for routine operations. On the other hand, most of the space launch world has gone to liquid bipropellants. You can throttle them, you can stop them, you can restart them, but you get all these benefits at the cost of complexity. And that added complexity adds in reliability issues. So you end up with something that performs wonderfully when it works. If it doesn't, you generally end up with a catastrophic failure, as we've seen in so many new rocket launches in the last few years, because you get that complete mixing of a load full of oxidizer and a load full of fuel, and it all goes up in a nice big fireball. Hybrid engines, they're low cost, they're simple to design, but they've got all kinds of other problems. They're difficult to throttle properly. starting and restarting can be difficult. We certainly struggled with it early on. And you get combustion instabilities. So you end up with irregular thrust and poor performance out of it. We set out to find a way to fix that, to bring that simplicity of a hybrid rocket engine into something that was commercially viable. And with our Vortex hybrid, we think we found it. We have, and I'll show you some videos of it firing, a hybrid rocket engine that performs like a liquid bipropellant. Flat thrust curves, solid repeatable throttle response, and very high efficiencies, ISPs in the high 290s to 300s, depending on your configuration. And we do all of that, going back to our discussion on alternate fuels with recycled plastics. Now, we didn't set out to go find a way to use recycled plastics for rocket fuel. We set out to solve a physics problem. You know, how do you make a fuel grain that doesn't suffer from all of the other problems, things that like Richard talked about earlier with the sloughing and chunking that you tend to get out of hybrid fuels. So we looked for something that had good thermal response under combustion, but was stable in normal temperatures and structurally rigid, and worked our way into thermoplastics. And from there, narrowed it down into high density polyethylene, which chemically is very similar to kerosene. With high density in polyethylene and first nitrous oxide and now liquid oxygen, we got the performance that we were looking for. And so it was great. We had a plastic burning engine. Where did we get the recycled part? I was talking with one of the customers that we have lined up for launch once we're up and operational, down in Brazil. It's a company that is building nanosats that will use hyperspectral imagery to track plastic pollutants in the Amazon basin and off the coasts of Brazil. And I was waxing eloquent about the safety and the reliability of our engines, and the fact that when it does fail, you'll get a pressure release from whatever's in the combustion chamber, and then combustion will cease, rather than a fireball with all of the fuel and oxygen going at once. And they just sort of looked at me and said, "That's interesting, but are you using recycled plastics?" And I had to admit I didn't know. So I came back home, talked with my engineering team, and asked them, "Could we use recycled plastics for this?" And the answer came back, "As long as it's the right purity, sure, no problem." Went to our supply chain folks. They reached out to our provider, and the answer we got back was, "Oh, you're already using recycled plastics. If you wanted new stuff, that's more expensive." So we had been pioneering recycled fuels from day one and not realized it. What makes it possible are these two patents. We've got an oxidizer injection system that essentially creates a vortex in the oxidizer flow in the combustion chamber that sustains it all the way through the end of the engine. So you don't get any of the worm trails that you tend to get in hybrids, or coning effect as your oxidizer loses more and more contact with the fuel as it goes further down the fuel grain and then ends up just shooting out the nozzle. We're running a hybrid, but we run a very oxygen poor exhaust, which is not common in hybrids. And then a patent on how we're doing the fuel grains, using additive manufacturing to lay down a repeatable, consistent fuel grain with no gaps, no voids, the exact same fuel grain every time. Those two put together give us the performance that we've been seeing in our engine. And since what we've done is design a design model, if you will, it's scalable. We can do this at 150 pounds of thrust. We can do it at 5,000 pounds of thrust, largest we've done to date. We can do it at 22,000 pounds of thrust, which we're gearing up to be firing in just a few months. And we can do it in short order. We were doing a project for the United States Army about this time last year. They challenged us to show that we could use a hybrid in a small form factor. They gave us the specs for the Hellfire missile and said, "Go see if you can do this." 6 months later, we had it on the test stand. 8 months later, we had the vice commander of Army Futures Command in our labs watching it fire. So Does it work? I'll let you guys decide. Here on the left, first is our 5,000 pound thrust test. You'll have to forgive the video. It's a little shaky. This is an early test a couple of years ago, and our camera wasn't really up to handling the load from this. But it's beautiful to see the shock cones that form inside the plume and stay right where they need to be, showing the stability of the engine. Like I said, that was done with nitrous oxide, one of our early tests before we moved to liquid oxygen. Here on the right is a test from just a few weeks ago when we had folks from the Army out. This is that 2,000 pound thrust missile engine that we were talking about. We were designing going to design something like this anyway to test our ignition system. Richard mentioned before the difficulties in igniting hybrid rocket engines. We've definitely felt that, running into all kinds of problems with different pyro igniters. So we went a different direction. We have a laser-based ignition system that doesn't require any pyro materials at all. The nice thing for that is that means our vehicle is completely pyro-free. The engines are inert plastic and liquid oxygen when they're not under firing conditions. The stage separation system is mechanical, and the ignition system is a laser. So this one was a throttle test. So you can see the engine start up. We've got it through welder's glass so we can get a better look at the plume on this. And you can see the plume and the shock diamonds change as we go from 2,000 pounds of thrust down to 1,000 pounds of thrust and then back up again. 2,000 there, down to 1,000, back up to 2,000, and then shut down. And it likes itself so much it wanted to play again. And on top of all that, you're talking about spaceports and communities. We are doing this inside the city of Cocoa city limits. You can see our test facility there on the upper left. All of our tests to date, with the exception of two, one initial test done at Florida Institute of Technology before the city of Cocoa would let us test inside city limits, and one flight test we did out at the Mojave. Everything else has been done in there, all the way up to the 5,000 pound thrust. As you can see, we have neighbors. The city of Cocoa has actually changed their zoning ordinances after working through the science on this with us, and allowed us, and by exception any other hybrid, to test inside city limits. So we're doing this with full cooperation with the city and with the fire department. Their experts come through and go through every test procedure we have. But they're perfectly comfortable with us test firing a 5,000 pound thrust engine in an industrial complex. So not your usual engine test site. Now, that said, the 22,000 pound thrust flight engine for Dauntless, we have a new test site at a little further back, remote, still only a few minutes drive from this facility. And you can see that there at the bottom. The facility is up and running. The engine is still in production at this point. But I'm anticipating it firing sometime within the next few months. And then talking about building infrastructure, we also have been granted a launch site out at Cape Canaveral. And I bring this up in particular because this shows flexibility here. And this, I think, is something of a model for future spaceports. We're sharing this site with Phantom Space. Phantom Space is a traditional liquid bipropellant kerosene LOX vehicle. This will be, to my knowledge, the first true multi-user, totally commercial launch site in the US. It may look familiar to some of you looking at the picture there on the left. This is where SpaceX is landing right now. You see, still see the remains of their logo on LZ2 to the upper part of the screen. They will phase out using this facility at the end of this year, moving to pads they're building at their launch sites, and we'll move in and start prepping this. We're intending both of these launch sites to be compatible with both vehicles, with both companies able to flip back and forth at need. So, a lot of things going on. I do want to point out or call out one thing for my folks as well. You can't be focused on the science all day long. And so we have really leaned into the environmental aspects, the green nature of our rockets, and what we're doing in the space industry as a whole for mankind. And so you'll see our people here in Florida out on beach cleanup, on STEM outreach. And I've got to give a shout out to the men's over 65 softball team that we sponsor. Not what you would normally expect from a rocket company, but there's actually a couple of investors for the company on that team, and they're not half bad. They're the Florida state champs for last year. With that sort of pitch on what we're doing, I'd like to open the floor to questions anybody has about us, what we're doing, and our fuels.
One of the things I'd like to point out is that it is stable, which makes it very important for developing a spaceport. A lot of places will not allow a spaceport because of the fuels. So this doesn't explode like some other fuels might. And
Right.
so you're able to actually go into areas like Coco where you would not be able to go before. You would have to go out in the middle, where it was in the middle of the ocean or something like that. So this is why this is important.
Yeah, Izzy, it's a funny story, but it's telling. As we sat down working through with the FAA and with the 45th Launch Delta, the Space Force folks, safety folks here, we had to talk through the process for mission ending if anything goes awry, if we go off course. And the usual approach is you have a system that will detonate your engines, and that shreds your vehicle and lots of little pieces fall down. And they kept asking us how we're going to destroy our vehicle if the launch fails. And we keep telling them that we can't. The engines won't have enough explosive potential to destroy the vehicle. And slowly you could see the light go on. And they realized we'd have to put additional explosives on the vehicle in order to destroy it if it goes off course. So instead, both they and the FAA are doing the logical thing, and they're letting us fly with a flight termination system. So instead of detonating the vehicle, we'll shut off the valves, close the oxidizer flow to the engines, which will cease combustion, and vent the tanks, and let a single piece of plastic and carbon fiber fall to the ground with payload.
And this is considered to be a green rocket. So because, it doesn't expose more chemicals into the atmosphere.
Yeah.
And do you want to talk a little bit about that part of it?
Absolutely. Obviously, as Richard was saying, hydrogen and oxygen is the cleanest you can get in a combustion. But when you think about burning plastics, you think about oily smoke, bad smells, hazardous chemicals, all kinds of nasty things you don't want to deal with. We don't get that. You do whether it's from our actual observations of the vehicle or from NASA's chemical equilibrium analysis studies. What you get out of our mixture of LOX and high-density polyethylene is largely water vapor with a little bit of carbon dioxide and a small amount of carbon monoxide tossed in. And that's it. The trace elements beyond that are in millionths of a percent, and none of them are hazardous. So we have a clean exhaust, as well as cleaning up the environment by pulling waste plastics into the fuel.
Awesome. So some questions, please.
Could you I'm on your website, which is great. Could you just touch on briefly in layman's terms, how do you go from all of those bottles on the beach to your actual having it in the fuel form that you use in your rocket? What is that process?
Right now, we're using 99% pure post-industrial waste. So the manufacturing plants that make those bottle caps, milk jugs, and 1,000 other consumer items made out of high-density polyethylene have wastage that then would go into the landfills. We're using that. We're not taking things out of the traditional, throw your bottle in the recycling bin and use it yet. There's some ideas that we're looking at that allow us to get the purity levels that we would need out of consumer recycles. But for where we are right now in R&D, that's a problem for the next round.
But chemically, it's essentially the same core, right? That's awesome.
It's exactly the same material that bottle caps are made out of, milk jugs are made out of, components in cars are made out of. There's thousands and thousands of common consumer items made out of high-density polyethylene. Medical waste, a lot of the bags and IV drips and things, tubing that you see in hospitals is high-density polyethylene.
Awesome. Okay, are there any other questions?
Not so much a question as an observation.
Mhm.
I would kill for shock diamonds like that out of a hybrid. That was awesome. Absolutely awesome.
Thank you. That's when we knew we really had something, when we could see the mock diamonds form and sit, not move, just sit, and then respond as we manipulated the throttle, watch the mock diamonds shift. Yeah, that's when we knew we had something well beyond a traditional hybrid.
Yeah, it really does look beautiful, the output from that engine.
Thank you.
And I would like to also note that when he said additive manufacturing, that's 3D printing.
Yes.
So if you're looking at careers, 3D printing is quite the thing to consider.
Yeah, let me expand on that a little bit, Izzy, because the fuel grain is 3D printed in plastics. And we have a one-of-a-kind custom printer that we use to make those fuel grains. It's got a build area of 5 foot by 5 foot by 20 foot. You know, just a massive machine for a plastics printer. The injector that we do, that patented injector system, can't be subtractively machined. What we're doing with flow patterns on the inside to produce that vortex requires metal additive manufacturing. So really, the technology to do this has only come about in the last few years. The Dauntless engine, the smaller engines we can get away with an ablative nozzle on. The Dauntless engine, the amount of time it's going to be firing and the power it's got, we need a cooled nozzle. So we have developed, using additive manufacture, a copper alloy LOX cooled nozzle. So our liquid oxygen will flow out of the central tank. If it wasn't clear in the videos, the rocket here, what looks like solid boosters on the side are actually the main engines. The central core is just a LOX tank feeding those 6 engines. So it will feed out of there into the nozzles, heated to supercritical status, and go through the injector as supercritical. And that, again, requires additive manufacture to make.
So wonderful technology, and I'm excited that our schools in Kentucky, anyway, there's some that are teaching those particular certification programs. So, wonderful. All right. Thank you so much for that. And we're going to move on to Derek Harris, which is Business Operations Manager at Skyrora and the CEO of Ecosene, which we heard a little bit about earlier. Derek is a new recruit to the space sector, having spent the majority of his career in the financial sector before electing to join the space sector with Skyrora over 5 years ago. He can be found normally concentrating on suppliers, clients, and spaceports while pushing towards sustainability and environmental responsibility at Skyrora Limited and Ecosene Limited. So welcome, Derek, and take it away.
Well, thank you very much, Izzy, for welcoming and inviting me along. And I have to say the exact same as what Richard said. The minute I saw those diamonds, I knew exactly what Richard was going to say. So it's great to see those coming through, Robert. So well done. Hopefully I get to talk to you if you're going to be at Satellite 24. I might get to see you and talk a little bit better in person. So as I said, I'm very new to the space industry. I'm not an engineer, which Richard will point out to you. But what I did do when I came in was to evaluate what was happening in the space industry in Scotland and the UK at the time. And it was to try and help set the core values of the company. So through education, looking at what was coming up. And that is when sustainability really did start to strike and show its head, from sustainability around the engine test sites to where the launch sites would be, to basically building it in through design through the entire program for Skyrora. And this is where the idea of Ecosene came out. So for me, that it's been great, and I'll bring up a presentation in a moment to go into that in a little bit more. But I do think, and would like to shout out again Richard's company of AstroAgency. He mentioned the sustainability roadmap that Scotland has done. That was done in conjunction with AstroAgency, and I think it was Optimat as part of the Scottish government. And what we're seeing here in the UK is we're looking at basically how to reinvent the wheel a little bit. It sometimes feels like, but it is looking at what the US has done, what Russia has done, and ESA has done to see where it can be slimmed down, whether it's the footprint of the spaceports and things like this. And I think that's really been part of the essence that we've put into Skyrora and Ecosene, is that, and you'll hear me refer to it as environmentally responsible, because until we get to that stage where it is oxygen and hydrogen and such that we're firing off, responsible is what we have to be as companies. We can't really hold our hands fully up and say we're fully green yet, because what we're doing is taking the right steps in that direction. So as I say, part of that led to Skyrora putting some money in and bringing forward an idea which is around the ecosystem. So I'm just going to share my screen at the moment. If you can let me know if this comes up okay there. Perfect.
We see it. We see it.
Excellent. So when we were looking at Ecosene, as I said, it was all about what we could do and how we can make things better. We looked at the oxidizers, and as has been previously mentioned, we use high test peroxide. So the outcome of that is basically, for any chemists in the room, H2O2. So it's this water, basically it's steam and oxygen. So you can't really get much cleaner than that. So it really had to be something to look towards the fuels. And similar to what Robert and his team have done, we ended up looking at plastic, whereas it looks like Robert had started and then realized they were using the plastics. This was a bit of a side project for us. We've got some figures on the screen there showing the sort of plastic problem worldwide. And when we actually looked into it, you were seeing how much was being recycled, what was being incinerated, what landfills, or what was actually being dumped and leaked into the seasons. So there's a huge amount of basically plastics, but this usable material that were being wasted. Only 12% was actually being properly reused to do something. So it was at that point the team decided, well, what could we actually do? Again, looking through, we looked at Europe, looked at what they did with it and seen who exported, who imported, looking at Scotland, the teams in Germany and Ukraine and such, where our team is situated. And that was when it came up with a similar idea to look at it. So we've got here a lovely just little graph showing basically the incineration throughout Europe there. And it was, well, with all the new regulations coming into play, what could we do? So in 2022, the UK had a plastic packaging tax coming of £200 per tonne on those packaging for anything less than 30% recycled. So this is really when it goes out the door or goes to the waste clinics and such. So we thought, well, this is where we want to try and get our feedstock from to make these fuels. And this is where we came across the idea of taking it and putting it through a 3-stage process. The first, pyrolysis, to take it down to the heavy oils again, and then using cracking and hydrotreatment to sort of bring that back up. And something that Scottish people are very, very good at, we started to look at distillation. So instead of whiskey, we're looking at different fuels for this one. So if we take it to the very basic stage, we've just got out those oils, but at the much more advanced stages, we can bring out diesel, gasoline, kerosene. And what we're finding is these were able to be used to a sort of aviation grade, rocket grade, and maritime grade as well. So we've got here just a little bit of a breakdown. So normally the feedstock that we have been looking at is polystyrene, polyethylene and polypropylene, I think it is, for that purpose. And again, they don't need to be the cleanest of the clean. We can take your bags from the supermarket, your bottle tops and milk jugs, or as I like to say in the UK, we can even take your old kebab box, which is made out of polystyrene, or your that wrapped your TV, and put it through the system to give it that second life. The whole system runs off. It's not too energy intensive, and the plant actually uses 5 to 10% of its own gases it makes during this process to help run it to go through. The full scale of this can fit into three 40-foot containers. So everything with Skyrora when we look to launch is about limiting our footprint. So having basically to be able to make our own fuel and having that in 3 40-foot containers just sounded like a great idea to us as well. But that's when it actually got a little bit bigger. And you mentioned earlier that things like cell phones, MRI scans, all of this have came from space advancement, innovation, and technology. And that's when we started to think, well, what else could we do with this? So we took a look to see what the sort of energy per kilogram and the CO2 release was, to see, is it actually going to be a bit, is it dirtier when we're making it? Or is it actually better and cleaner? And so we looked in, done some calculations, which we've got on the screen at the moment, over the displacement of emissions and such, to see how that worked out. And when we became positive about it, that's when we moved forward. And really, we've started to look at Ecosene as a business on its own. So we have now tested it within our 3.5 kilonewton engine, our 30 kilonewton engine, and hopefully pretty soon our 70 kilonewton engine in Scotland should be tested on this as well. But some of the unique points with it is what we're finding is we can customize it to depending on the fuels. So it's really, when I said it's like making a whiskey, the other option is actually it's like making a cake. So if you put a lot more polystyrene in it, for example, you get a higher grade of fuel that comes out. It's more pure. It's more towards the RP1 aspect of that. Whereas if you use a lot more of the sort of polyethylene bags and things, it's a bit lower quality, but it's still good there. So from a sort of business plan point of view, it was up to myself then to decide, well, where do we really want to market it here? So this is just a quick overview of the process through there. So I had to think, when it comes to rockets, yeah, it's great, but when we figured out for our own vehicle, it would take about 45 tons of plastic per launch. It's a huge amount. Is it likely we're going to get others to come and sort of take it with us and work on us with us? There may be some adopters, yeah, but from a company point of view, it may not be viable and worth that investment. But what we have found is that maritime is actually one that I'm really looking at on the back of this as well, with their new laws, especially around sulfates and nitrates release with their emissions. We have had huge success in cutting the amounts of these within this fuel. So it's something that we sort of pivoted a little bit from, again, working with the sustainability development goals for those purposes. I think if I've got this with a couple of words here, but I've got another screen that I just want to bring up if I can here, which actually has a comparison between the fuels, which hopefully should have came up now. It's a bit of an older one, so I apologize for the screen here. And that's got it down there. It's 850 times less nitrates and sulfates, pollutants in the traditional kerosene once it has went through this process. And we can see on the right-hand side the ASTM, which is for the RP1, compared to what we're getting from an independent lab for density smoke points and sulfur and such there. And we're seeing how much, how close we're getting to this. So for me, it's quite an exciting step to be able to bring this not only as a bit of a selling point for Skyrora and their vehicles, but also to see how we can sort of bring this into other markets and just showing that this is one of the reasons that space deserves that money for investment. It's the innovations that come out of it. And I think it's exactly as you said, Izzy, and what Richard said. You spend the money down on Earth for it because most of the benefits are coming back to Earth. But I'm happy to try and answer any questions there in and around this. So please feel free.
Well, I love the point that you made that you're making recycling not just something that we have to do and is a cost but you're turning it into gold. You're turning it into something that people will go out and try to get to use, and because it's going back into a lot of different systems. And I love the maritime, part of it, because that's a very good example. So
I think for
go ahead.
myself with the maritime side of things, if you could put these on the back and have ships going past the Pacific or the Atlantic trash patches and being able to scoop up, even if they don't want to have the full container sets on there, even turning that into the sort of crude oil bases and bringing it back to be properly developed. This gives just a huge game changer for things. And for me, that's just exciting. As you said, it gives that reason for another reason, not just because someone says we need to clean up the earth, but well, it costs a lot of money to put a rocket into space. If you're getting feedstock or basically free feedstock in that regards for your fuel, and it's not coming out any more expensive, it is very much a no-brainer for it.
Exactly. So I love that. So please, some questions.
If I can jump in, Derek, I have to ask, have you guys looked at doing anything other than kerosene on it? Because what you've described sounds an awful lot like some of the thought experiments my team has done on how we answer the other gentleman's question about taking consumer waste and turning it into the polyethylene pellets we need for our feedstock.
Yeah, certainly. Well, at the moment, what I've been trying to do is to get funding to build a bigger demonstrator station. So at the moment, the most we've been able to do is about 1 ton per day of trash. I'm trying to get a demonstrator for about 3 tons that will be actually set up near my hometown of Pennycook and Midlothian with the local councils and authorities who actually pick up the trash. They actually separate it and then send it to either incineration or recycling. And we wanted to situate the plant next to it so we could just take it straight away, anything that was going to be incinerated. So that could be commercial waste, that could be household waste for that purpose, medical waste, depending what comes into that site. So far, my understanding, we have used household waste and we have used commercial waste. I don't think we've tried the medical waste that you guys seem to have so far, but
we've done thought experiments on it, but nothing more. You guys have actually done it, at least.
Yeah,
use the usable fuel.
I'm very lucky, and this is one thing. We have a great team at Skyrora with Ecosene that's a mix of British and Ukrainian heritage. So I shout out to my brothers and sisters in the team from the Ukraine and such who have just brought wealths of experience and sometimes out the box thinking from what we wouldn't normally do. And then you get that backed up with the Scottish mentality of, okay, this is how you're supposed to do it, but how can we do this quicker, better, cheaper, so we can then spend that extra money and go to the bar? And that's really where things are working out.
And it just blows my mind that you say
that sounds an awful lot like them.
It just blows my mind saying that you can only do 1 ton a day. And if, there were, how much could we eliminate on all the garbage if there were like thousands of sites that could only do 1 ton a day?
That's it. It's something that we have had a lot of interest in, and I'm hoping over the net, as I said, that I think the big thing and the gate key to open it up to a wider commercialization is definitely going to be the larger demonstrator when we get there. But as I said, hopefully next time I'm on, you'll have the good news saying that the demonstrator will be built by in the next year or something like that, and welcome you all to visit when Scotland starts doing its maiden orbit launches as well.
So wonderful. So any more questions? Paul, this has given you a lot to chew on, hasn't it?
Yeah, it's just fantastic. Solving solving something while creating solutions for the future. It's just fantastic to see this convergence. And I mean, I just imagining, fast forward a bit, where there's a shortage of plastic, because this becomes like the fuel that we need. And next thing you know, there's a premium. That's just, it'll be interesting. We fast forward a few decades where we could be on that.
Yeah, I think for that, Paul, for me, it would be a great mic drop moment to be able to walk up on stage and say, I'm sorry, I need to wrap the company up for bankruptcy because there's no more plastics.
There's no more trash. We're so sorry. That's where the bees come in. So
Yeah, exactly.
Well, it's a great example also of how going to space on a rocket, that's like, that's like the fun thing. But it's all the other things that you're creating that has market value for so many other things. And that is one of the things that I try to also stress, is that going to space is great and wonderful, but you need to have the market down here to actually fund it. And a lot of particular companies, they try to get the grants, but that's not sustainable. So we're talking about sustainable on all the other stuff, but it's not sustainable on monetary wise either. So you have to make a profit, and you have to do business, and you have to bring something to market other than the fun bits that are going up to space.
Or you have to bring the price of going up to space low enough that you're making a profit.
Yes.
That's certainly
Yes.
our approach to it.
Well,
Yeah.
you have a lot that you're doing as well that can go into so many different other avenues. And
Well, I think that's it. And Robert hit on that. The additive manufacturing, whether it be metallic for engines, plastic for the fuels, and such like this, is going to be a game-changing experience. We're probably at the slowest that innovation is going to go for the future now, where we are right now, and it is only going to pick up. And this is why it's great, sort of seeing what the other companies are doing, because as I said, well, in Scotland, yeah, we're trying to push that sustainability and the greener angle, but at the end of the day as well, it does come down to that financial aspect. But if Robert's pushing this way to try and put his rocket cheaper and to make it greener, then I have to do the same thing. And then I might actually have to listen to Richard and put landing fins on the bottom of the vehicle, or convince the team to do that. But all of these things then come into play. And that's just a great market dynamics with the innovation that's ongoing at the moment. And I think the UK coming into that market to play throws a little bit more of a couple of question marks in there, whereas the US and Russia and Japan and India have really had it their own ways. I think now really we're beginning to see the utilization of space globally and commercially, and that will only force better changes and better things if it is actually held in the correct regulations.
well, and you've got the right people on it. That's one of the things about people that are going to space, is that they got the smarts too, to be able to solve the problems that we have on planet. So, yeah, I love this industry.
I was trying to think of something hard to try and catch Derek out, but I can't think of anything, unfortunately. He did an excellent presentation, so well done, Derek.
Yeah,
Thank you.
It's a fascinating evening, listening to both Richard and Derek, and hearing what else is going on over there in the UK. I mean, we'd followed both a little bit, but it's really good to see sort of the inside on what folks are doing, and seeing how much innovation there really is in this industry across the world.
And it's something that needs to be talked about.
So yeah, in your work with conferences, are there any ideas of putting together a conference specifically on these kinds of, like, addressing fuels and things?
That'd be interesting.
That you just planted a seed. That sounds like an awesome idea. So we will definitely look into that, because I think it's something that needs to be talked about. I think too many times there's a narrative that goes around saying, we shouldn't do this, we shouldn't do this, we shouldn't do this, but we are doing fabulous stuff, and it just needs to be shouted from the rooftops. So All right. If there's no other questions, I want to thank Richard and Robert and Derek for their time tonight. I know it was tough for the United Kingdom, and you're late there, so I really appreciate it, and I look forward to seeing what you all do. So, and thank you for everybody that attended and is watching this. Next time is going to be economic development plans. So what's the first step you have to do on your spaceport? You have to prove that it's viable. And I hope tonight, some of what you've learned tonight will get into your plan in the future. So thank you for coming tonight, and please subscribe to spaceforkentucky.com and watch the past recordings on that website. So thank you so much.
And thank you for hosting us, Izzy. This has been a fantastic evening.
So we'll have to do some more of this. This has been good.
And it's 4 o'clock in the afternoon here in California, so this is a very reasonable time to hold these. So thank you all for.
What is it, after midnight in the UK?
Wow,
Yes.
that's a dedication.
Pretty much. But no, again, I reiterate what Robert said. Thank you again for the invite. It's been always a pleasure. And if any of you are at Satellite 24, please see me, grab me, or I'll try and pop by. And it's lovely to meet you all.
I'm working on being there. That is the week of March 20th, March 19th. So in DC. So I'm trying my best to get there.
I would like to say the same as Derek, but unfortunately, unlike Derek, some of us have to work.
Unfortunately, I won't be there, but we will have folks there. Our CEO, Kevin Loudermilk, will be there. He's a fantastic guy. So I'll tell him to look you up.
And Mary as well. And she is the marketing powerhouse.
Yes,
So.
that's a perfect description of Mary.
I'm excited. Thank you all, seriously.